want you to go over is calorimetry. So calorimetry is the measurement of quantities of heat. A calorimeter is the device in which heat is measured. Now, we will be able to make one that kind of looks like this. This is an actual calorimeter. We will not have anything like this. Okay. Assumptions. Heat lost equals negative heat gained by the system. Okay. So, obviously, we're not gaining the heat if it's negative. So, that's what we're talking about here. In a simple calorimeter, no heat is lost to the surroundings. Coffee cup calorimetry. We're going to use styrofoam instead of a beaker to keep heat in. What we're going to do is we're going to be adding hot solid metal to cool water. The water will heat up, so the temperature rises as the metal cools. Eventually, water and metal are at the same temperature. So we can see how the heat lost by the metal is going to be negative heat gained by the water. So if our Q of the metal is going to equal negative Q of the water, so our heat lost by the metal equals the negative heat gained by the water. Since Q equals MC, change in T, so this is the equation that we used when we were doing our specific heat. Our enthalpy or our energy equals the mass times the specific heat times the change in T. So basically we can say the MC change in T for the metal equals the negative MC change in T for the water. Oops. Okay, let me get my negative sign in here. It's not colored, but you'll be okay. All right, so we can look at this problem. Actually, I want to keep it here anyway, so I can go through it with you. So we have lead and we have water in this problem. We have a 358.11 gram piece of lead. So I'm going to go ahead and I'm going to color this. Oh, not blue. We're going to make it red because that is what I'm using for the lead. So that's our mass. Okay. 358.11. And I'm going to put my time symbol in there since I'm not going to have variables by the time I'm done here. Was heated in water to 94.1. So that's also referring to the lead. So this is being heated up to, was heated in water to 94.1. Okay, so that's our starting temperature. So for our change in temperature, we're going to have 94.1 as our starting, and we need our final. It was removed from the water and placed into 100 milliliters of water in a styrofoam cup. The initial temperature of the water was 18.7. So this is where we're talking about the water. Okay, so I'm going to put my change in T, 18.7. And I don't know my, hold on. That's my initial. Same over here. Oh, yeah, so that needs to come last because my final needs to come first. And the final temperature of the lead and water was 26.1. So this value is both of them. I'm going to make it purple because it's blue plus red. So we need to have 26.1 and 26.1 as our final temperature. So we need to take our final minus the initial. What is a specific heat of lead according to this data? Well, we know that water, we have 100 mils of water, 100 milliliters, it's 1 gram per milliliter. So this is important too because this is going to end up giving us our mass of the water. I would not expect you to know that off the top of your head, that 1 mil is a gram. But that is a common conversion. I do not have the labels in here, but obviously if we have C over here and C over here, our label is going to end up being the same, because our M label is going to cancel out when we divide by whichever side. Our temperature, the degrees Celsius, is going to cancel out as we divide by either side. So the only thing we have left is our C, which if we go back in our notes, the C for water is 4.18 joules per gram degree Celsius. I'm not going to put those labels in there because it's harder to type. So this is what you're going to have on the water side. This is what you're going to have on the lead side. So now you're just to the point that you have to solve algebraically for C. So you'll go ahead and multiply these together first. Well, sorry, subtract first because it's in the parentheses. Then you're going to take that value, multiply by this. You're going to take these, calculate that out, and then divide by whatever your value from over here was. So that's just solving algebraically. If you need me to work through this completely, let me know. But otherwise, it should just be solving algebraically for this C value over here. Okay?